Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. CH3, CH2, CH, Cl, CH, CH3, C, of CH3. Wait, let me reread. The structure shown is CH3, CH2, CH, CH, C, CH3 with Cl on C3, the CH, CH3 on C4, the CH, and O on C5, the C. But C5 also has CH3 attached, the terminal CH3. So the full structure is C1, CH3, C2, H2, C3, H, Cl, C4, H, CH3, C5, O, CH3, dash. Wait, let me recount. Moving on to the next step. Count the chain. Reading left to right, CH3, 1, CH2, 2, CH, Cl, 3, CH, CH3, 4, C, O, 5, CH3, 6. Carbon 5 has O and is bonded to CH3, C6, and CH3 branch. Actually, C5 has substituents, O and the CH3 shown below, plus it connects to C4 and C6, CH3. So C5 is C, O, CH3, connected to C4 and C6. That means C5 has bond to C4 bond to C6 O, and a methyl branch, making it a quaternary carbon with O. Moving on to the next step. The longest chain. The main chain contains 6 carbons, C1, C2, C3, C4, C5, C6 is equal to hexane backbone. And for the final step, number from the end nearest the principal characteristic group, O. Numbering from right, C6 and C6 is equal to 1, C5 is equal to 2, C4 is equal to 3, C3 is equal to 4, C2 is equal to 5, C1 is equal to 6. This gives O at position 2. O at C2, hexan-2-ol. CH3 at C2, 2-methyl. CH3 at C3, 3-methyl. Cl at C4, 4-chloro. 4-chloro, 2-methyl, 3-methyl-4-chloro, 2,3-dimethylhexan-2-ol. B uses hydroxy as a prefix instead of the suffix ol, which is incorrect when O is the principal group. C. Trimethylpentane, 2-ol implies a 5-carbon chain with 3 methyls, which does not match the structure. D. 3-chloro, 2,3-dimethylhexane, 2-ol places Cl at C3 and methyl at C3, but correct numbering gives Cl at C4. Therefore, the correct answer is A. Therefore, the correct answer is option A.